In one of the last sections, we were taking a look at the classic 5 reactions. And that was the combination of different chemicals. But the question is, how do these chemicals react? What are some other particular dynamics about these chemical reactions? And what we're taking a look at today is going to be the amount of heat that is produced in the reaction or the amount of heat that is needed in the reaction. So, for example, we're going to be looking at the heat, or we can also say the energy of the reaction. Okay, so just to remind you about our starting stuff in a chemical reaction. These are called my reactants. Again, if you're participating in an event, you are a participant. These are the things that are reacting. They're called the reactants. And this arrow means that they're going to be making something or producing something. And what they're producing is called the products. And there are 2 different types of reactions that deal with heat. In a combustion reaction, if you remember, we produced carbon dioxide, water, and one of the end products was also heat. When you burn fuel inside of your engine, or if you burn a candle, that's a combustion reaction, and one of the byproducts is heat. So what happens to the temperature over time? So we're going to sketch an XY graph right here. And over time, okay, this is when we start, and as we progress over time, what's going to happen to the temperature? In a combustion reaction, we start to burn our fuel, and it produces heat. So over time, the temperature increases. So it's going to get hotter. So if it's getting hotter and it's in your hand, you're going to feel the heat. The heat is coming from the reaction and it's going into your hand. So in this type of reaction, the heat is exiting. The heat is exiting, and since it's exiting, it's called an exothermic reaction. The exiting is the X, so we have an exo. Exo means going out, like an exoskeleton. Crabs have an exoskeleton on the outside of their bodies. So exothermic. Therm means heat. So exo means going out. Therm means heat. Like a thermostat on the side of the wall inside your house or in a room, that thermostat tries to keep the temperature or the heat the same. So heat is going to be coming out of this reaction. The other type of reaction is sort of a little more difficult to understand, and it's the opposite of this. It's called an endothermic reaction. If exo means out, endo is going to mean in. We have an endoskeleton. So what happens is, over time, the temperature is going to decrease. So it starts off warmer and it's going to get cooler. So in order for this to happen, imagine that you have a substance or 2 substances that are sitting in a test tube, and they begin to react. And what happens is it starts to feel colder in your hand because of that chemical reaction. What's happening is the heat inside the test tube is going into the chemical reaction itself. So the heat goes in the reaction. It enables the reaction to occur. So since heat goes in, it's called an endothermic reaction. Endothermic. Endo means in, and again, therm means heat. Melting ice actually is an endothermic reaction. If you put the ice inside of the water. The heat is then going to go from the water into the ice. And because of that, it's going to make the surrounding water cooler. It's going to feel cooler because of that. So we have these two reactions. We have an endothermic reaction and an exothermic reaction. So the endothermic reaction, our example can be melting ice. So if you have your ice right here, and here you have your liquid water, where is the heat going to go? Well, in order to melt the ice, there's more heat in the water. The heat goes from the water to the ice. Heat goes from water to ice. An example of an exothermic reaction, this would be a combustion reaction. So combustion reaction. It produces heat. We burn a fuel. Burning fuel releases heat or produces heat. That heat then exits and comes out, and then we can feel that heat. But in this case, the heat is going into the ice to melt the ice.